Well, we just established these double angle formulas, so let's see about using the double angle formula for cosine. Now, this was the one that had the 3 different formulas, and you might say, well, how do I know which one to use? Make it easy on yourself because you were given sine. If you use this one or this one, you actually have to find cosine. So to make it easy, just go ahead and use the cosine 2 theta equals 1 minus 2 sine squared theta. And I know what sine is, which is 3/5 squared. So from here, I just have a simple formula, 9/25. Let's go ahead, I'll go under it, change. I know I'm gonna need a least common denominator. And then 2 times the 9, 18/25, and then I get my answer. So that's how you decide on which one of these to use, is it's dependent on what you're given and what you know. And we should mention here that we don't have to worry about, you might say, well, why didn't you worry about the sine of cosine in this quadrant? Well, we didn't have to worry about it because we never even used the cosine in the formula. All right, next item up for bid is let's establish the tangent double angle formula. So we're going to do the same thing basically. If you remember, the tangent sum formula we did last section was tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. All right, so we did that last time. Well, we're going to do the same thing with the double angle. That's a double angle, so we'll separate it as theta plus theta. And now just looking up above, I'm just going to replace everything with thetas in my formula. Theta all over 1 minus tangent theta, tangent theta. And so of course the top becomes, we're adding, so 2 times tangent theta. And then the bottom, that's being multiplied, so tangent squared theta. All right, and that gives us our formula. So that's pretty easy to derive based off of using the sum formulas. Now, as you're gonna see, you can rearrange these formulas to use depending on, again, what you know, okay? So if we start with this cosine 2 theta, and this is the one that we actually used, I could rearrange this, right, without, it's just algebra. With just algebra, meaning that all I've done was move the 2 sine squared theta over here, I move the cosine 2 theta over here, and then I divide by 2. So this gives me another format, okay? So this would be a good way to find sine if I knew cosine 2 theta. Once again, I can rearrange this same formula, but in this case using this formula for cosine 2 theta. That's why we have all the different formulas. So I can rearrange. And then finally, I can do the same thing with tangent. I can write it as sine over cosine and then write it as these. Of course, the 2's cancel. And it just gives me these different formulas. So all I've done is use all the formulas we've had before, but either with the identity here or just pure algebra, I've done some rearranging. So let's see how we can use this, and I'm told to write an equivalent expression for cosine to the 4th power of theta that does not involve any powers of sine or cosine greater than 1. All right, so let's see what we're going to do here. So the first thing I'm going to do is break this down into cosine squared theta squared. Because now, notice, I'm going to use this formula. So this is going to be 1 plus cosine 2 theta over 2 squared. All right, from here, I still have powers, so I got to get rid of them. So from here, I'm actually going to FOIL this out. So let's just go ahead and write it out. So you remember that squared means this, multiplying it times itself, cosine 2 theta over 2. So now I'm going to FOIL out the top. So I'm going to end up with 1 plus 2 cosine 2 theta plus cosine squared 2 theta. So that's just foiling this, I missed it, foiling the top out. And then of course I have to multiply 2 times 2 on the bottom. Now I'm going to separate my fractions. So I'm going to write 1 over 4. I'm going to write 2 cosine 2 theta over 4. And then I'm going to write cosine squared 2 theta over 4. So that's all I've done is separate these fractions out. All right, so I still have the 1/4. Here I could cancel, right? So that's all I'm going to do. Plus, and try to make my plus look better, plus 1/2 cosine 2 theta. This piece, I'm just going to bring the 1/4 out front. And then notice, this is very important you notice this. I'm going to use this formula, but the formula is just for theta, not for 2 theta. So what I'm going to have to do is I'm going to have to multiply. If I multiply this by 2, I have to multiply that inside by 2. So that becomes 1 plus cosine of 4 theta over 2. Okay, so it's important you recognize how'd you get the 4? Because up here, this is only theta, and I actually need 2 theta, so I need to multiply 2 theta times 2. All right, and continuing right along, I have the 1/4 plus 1/2 cosine of 2 theta. I'm going to distribute this out and then separate my fractions. So you'll see I'll have 1/8, and then inside the 1 plus cosine 4 theta. All right, and then I have my 1/4 plus 1/2. You see the last term is really the only one I'm messing around with. And multiplying, distributing this out now, plus 1/8 plus 1/8 cosine 4 theta. And now I can kind of combine some terms, so I know that 1/4 is the same as 2/8. So I can add it to my arrow. I can add it to that one, which gives me 3/8, and then plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. All right, so all I did was I wanted to write this where I didn't have any powers, and I don't have any powers of sine or cosine greater than 1. All right, we'll continue on the next lecture.